Thanks for joining me. I'm going to call Charley Charlene for this because it gets confusing otherwise. We've got Charley beaming in. Thanks for joining us too remotely. I'd like to begin with some quick intros, panelists, a little bit of a history of the project for those who aren't super familiar with it, and then get into the questions. So on my left here is Akimenyon, previously the director of Tendermint Labs, the founder of Occlusion, which is a validator, runs on the Cosmos Hub as well as some other networks, and the founder of Sommelier, a Cosmos SDK chain that manages Uniswap positions. Zaki, it's a little bit mean, but I'd like to ask each of you, why are you on stage with me? Why do you matter?
So I've been working on this project for 7 years. I've been working on committing code to Tendermint. I've just been part of the project for a very long time. So I have a lot of context, and so I hope to share some of that.
That's an understatement. We have Charlene. Charley, welcome. You are the IBC product lead at the Interchain Foundation. Previously, you were an engineer at Centrifuge. Why are you an interesting person to have on stage right now?
So in contrary to Zaki, I joined at the beginning of this year. Prior to that, as Willie said, I was working in the Ethereum space. I'd like to think that I have a lot to learn in the Cosmos space, but also that I have something to contribute. And I just think IBC is honestly just great. I love IBC. So.
IBC maximalism. We've got Charley Noyes, partner at Paradigm Capital. Welcome, Charley. What is it that makes you so relevant to this conversation?
Probably the least relevant person here, but I recall showing up to an apartment in Berkeley back in 2017 with Zaki and Sunny, a bunch of the original developers when you guys were all still working at Tendermint. And after a 30-minute conversation that turned into 3 hours, I was like, all right, we're going to do Cosmos.
Cool. And I'm Billy Rennekamp. I'm the Cosmos Hub product lead on the boardage management at the Interchain Foundation. Been running the funding program there for the last year, where I work with all the different 40 or so entities that build core technology across Cosmos. And happy to be here. For those of you who aren't familiar with the project, as Zaki sort of mentioned, it's been around for a while. First versions of Tendermint began taking shape around 2014. The white paper was published in 2017, and the founding of the Interchain Foundation for the token sale. And the whole project really is based on this thesis that in order to solve scalability, sovereignty, and performance, that the future of blockchains is application-specific. There'll actually be an internet of blockchains, that all blockchains are important. They should have their own features that match their uses. And for that to work and to have the composability that we've seen to be so important across smart contracts, we needed an interoperability protocol, which is inter-blockchain communication. So throughout 2017-18, we worked on the Cosmos SDK, which makes it easy to build application-specific blockchains. 2019, we launched the Cosmos Hub. 2020, we worked on IBC, which we launched earlier this year. And now we have a bevy of extremely ambitious products, which are actually going to the hub itself to make it useful inside this configuration and this growing, really vibrant ecosystem of the Internet of Blockchains. So IBC is really kind of the crown jewel of this. As I mentioned, we're, I think, blockchain minimalists, all blockchains matter, but IBC maximalists. So Zaki, can you tell me a little bit more about IBC, what it is, and why it matters?
So why did IBC take us 6 years? So I think what's special about IBC, and people will start to see this more and more, is it was always, I think, obvious to us that this current ecosystem of bridges was going to emerge. In fact, in many ways, the centralized exchanges were the first bridges between sort of the early versions of many blockchains. And now we start seeing, as people engage with protocols more directly, all of the different bridging protocols come together. But the vision of IBC, I think, is somewhat stands alone among all of these things because what we wanted was permissionless bridging. So if you think about what it's like to be a person who is launching a new blockchain today, you have to go and talk to the wormhole people or go and talk to another bridging protocol people like the Chainlink people and try and convince them that your blockchain is worth the time and energy to set up monitoring, bridging, smart contracts, the custody risk, all of these things. It's just, and in many ways, this reminds me of what it was like to get listed on centralized exchanges, except we just have a different set of DAOs to negotiate with instead of negotiating with centralized exchanges. IBC is unique. IBC is the only protocol in this sort of interchain bridging world where you don't have to ask anyone's permission to connect to another chain, and you don't have to ask any permission to access all of the services on the Cosmos ecosystem. So anyone who, just yesterday, a team upgraded their Cosmos SDK chain and launched a stablecoin on Osmosis without really having to do all they had to do was upgrade their Cosmos chain, set up a relayer, and make a pull request against the Osmosis front end. That was it. And we can make it even more permissionless than that. But that is pretty close to a full permissionless bridging world.
Yeah, the front end is like the last mile of the delivery, sort of the Amazon thing. Charlie, Zaki just mentioned relayers. They're a super important component inside of IBC, but I think they're very poorly understood from the larger public. Can you tell me a bit about what relayers are, what their role is, and why they're so important?
Yeah, so when we think about IBC liveness, relayers are kind of like the heartbeat of IBC liveness. They are, in the way that the IBC client is very analogous to something like TCP/IP. It's the transport layer. It kind of has a way to generically package messages or arbitrary data types that can be transferred then over to arbitrary state machines. In that analogy, relayers are something like internet service providers. So a relayer is not someone who performs validation in the same way that validators on kind of bespoke bridges perform those validations, but they are really just responsible for ferrying the messages back and forth. And so the design of IBC has just decoupled the validation of a transaction from the actual transport of that transaction over to the other blockchain. And so a lot of times when people think, okay, I need to integrate IBC, the relayer package kind of comes part and parcel. But there are a lot of benefits to this. Obviously, the decoupling of the validation is a really important benefit. It's one of the primary and best security guarantees that we can offer as part of the IBC protocol. But also, and I can talk about this a little bit more later, the relayer as a business model that we have seen in other ecosystems like Ethereum, but now we will see emerging in the Cosmos ecosystem is something that we believe will also offer kind of exciting and important potential opportunities for people looking to get into the space.
I really like this metaphor that the relayers are like the internet service providers of the blockchain of internets, which is obviously a huge business in itself. But we're still just at such early stages that we're just trying to get these packets across in all the ways that we can. There's been a lot of talk about validators running relayer businesses or about having service agreements. I think that early days we saw the internet happen with your phone line was how you got on and you paid a phone bill to do it. Later on you had more dedicated ISPs and broadband. Zaki, you're a validator. Is this within your purview of something that a product offering, or have you talked to other validators who are starting to see this as a business opportunity?
So I think that it is going to be more common as a capacity that a validator has to offer. Because one of the things that validators are frequently in the position of is we are asked to validate new zones, new Cosmos chains. And if that Cosmos chain doesn't have a relayer, then you have to go find one. And so validators who are able to offer relayer services will be more appealing as early validators in Cosmos chains.
There's also this possibility that it's the users themselves who can act as the relayer, since technically anybody can do the relaying. There's a TypeScript relayer that can be built into wallets themselves, so it's like a user makes their outgoing IBC transaction and then decides to ferry it themselves. What do you think that looks like, Charlie? What are the current sort of work around that, and where do you think that would be taking off potentially?
Yeah, I mean, it's interesting you mentioned there are actually 3 relayer implementations out there at the moment, and they all kind of, they all relay transactions for IBC, but they're kind of intentionally designed for different use cases. So the TypeScript relayer that you mentioned, it can be run in browser. It makes it easy for a user to be able to set up, an in-browser relayer, and therefore they are handling the entire transaction from beginning to end. There's just actually no intermediary in between that they have to depend on. Obviously, not every user or not every application is going to be this workflow is not going to work for all use cases, and so the other implementations in Golang and in Rust are kind of designed, for the medium to larger size enterprises who have, very complex backend structures. They want to do very large scale relaying, large volumes of transactions, and the DEXs we have out at the moment, Osmosis and Gravity DEX, they rely primarily on these relayers to kind of handle the volume of transactions that need to be deployed.
Relayer incentivization is a big topic all the time. So, again, you can always just relay your own packet. You can be your own relayer with, say, the TypeScript one. But building in proper incentives directly into the protocol has been a feature that you really got prioritized this year and is coming to a close. Can you tell us a little bit about that?
Yeah, that was interesting. So before I became a software engineer, I studied law, and so I have a background in intellectual property. And when I joined the space, kind of like there was an interesting discussion about like relayers as a business and how that would play into the entire framework of classifying IBC as a way to move data around. And what I quickly realized was, like relaying is like internet service provision. Without relaying, you don't have a way to pass the packets back and forth. But it's kind of like there's like the technical side, and then there's this business side. And I think like for me, coming in from a mixed background, it was easy to see that while the technical integrity of something like IBC was really good, you really needed the entire ecosystem to be built around it such that it would be a viable business model. And so, when I think why would I run a relayer? One of the biggest points for me was, I should have incentives. I should be able to build a business model around this and be able to run my company off of this. And so, I think having now, as Billy mentioned, we've been working a lot of in-protocol incentives for relayers, such that I can stipulate, as a relayer operator, I can stipulate, cool, I want to relay packets that have these types of fees attached to it, and therefore be able to provide really like a sustainable and consistent income stream for myself. On the other hand, a blockchain, which relies on relayer operators for their infrastructure, they can incentivize packets and thus also have a certain sense of reliability and consistency in their throughput over to the other chain. So, yeah, I think it's one of those cases where it has to be both a business and like product design as well as a technical and really security-focused implementation.
You mentioned that the architecture is pretty similar to meta-transactions on Ethereum, and that domain's gotten criticized before because there's sort of a zero-sum for the people participating. They're all competing to relay these packets. If one person relays the same one and it was already done, they just had to pay gas costs and didn't get compensated. We have a couple things in place to stimulate that with IBC, refunds for redundant transactions. But Charley, Noyes, I would love to hear if you've given much of this thought, because at a certain point it really starts looking like minor extractable value, where you have all these relayers who are basically racing to the bottom to try to get this packet over as fast as they can and competing on these fees. I know I didn't prepare you for this question at all, but comes to mind now. I'm curious, you're kind of an MEV expert. Have you given any thought to this, or could you imagine what direction this will go? Will it become a bigger problem? Will there be more coordination methods that are required before it's a really great ecosystem?
Sure, so it's certainly MEV, and I guess like that's not necessarily a bad thing. But yes, it's certainly MEV. I think it will certainly be a race to the bottom. Some races to the bottom are actually helpful in the sense that like efficient market hypothesis, like optimal arbitrage is like an ideal race to the bottom. You want prices to price updates to happen as quickly as possible and sort of reflect like the quote unquote true underlying price as quickly as possible. So like those forms of like arbitrage race to the bottom, races to the bottom are like helpful. There are many such examples. There are also other examples of like cases or types of MEV which are less obviously helpful, and in which like the race to the bottom might have like social externalities or consequences for like undesirable consequences for users. So yeah, I guess it's difficult to say in the general case. Beyond that, I do think that at the boundary of like different trust zones, MEV is naturally emergent. So Phil Diane actually has a really good post on this called MEV What Do? And there's a section I think called interoperability under heterogeneous trust. And like the basic idea is that to the extent that there are like multiple blockchains, and this generalizes further, you could also like look at, for example, like MEV arbitrage between like Bitcoin and like some perpetual futures market. But like to the extent that you have multiple trust zones, whether they be blockchains or anything else, even to the extent that there is like zero MEV internally, like the boundary of those trust zones, like does generally create MEV. Yeah, whether this is like controlling Bitcoin transaction ordering in the context of like centralized exchange arbitrage, or like in this IBC example, sort of the incentives and resultant behaviors of relayers. So I would expect the debates would be emergent in any such context.
As we have more networks coming online with IBC, I've often heard that one of the emergent business models for validators will be almost sort of, these MEV as a service. They're the people who are first in line to help validate transactions, and as you said, there can actually be good parts of MEV. It's a business for these different configurations, which sometimes it's not purely extractive. But I'd be curious if we see a combination of that with relaying transactions themselves, being sort of like a suite of messages that can be executed sequentially, and you sort of have services with validators. I know this is sort of a nascent design space for businesses, but it actually reminds me of the area that I wanted to talk about, because being somebody who contributes a lot to Cosmos, I felt like I should give some of my own updates on our work. And that all of this comes from asynchronous transactions. When you have multiple application-specific blockchains connected with IBC, they're asynchronous. If you remember James Prestwich's talk a couple years ago at DevCon, Ethereum sharding is not going to be fun. People weren't prepared to wrap their heads around asynchronous cross-chain transactions. Right now, we're working on a suite of products for the Cosmos Hub, and one of them is Interchain security. So it's our version of shared security. There's two versions of it. One is the full validator set of a blockchain can be passed down to a child chain, and that's used to populate their validator set. This is a way to kind of like horizontally scale a blockchain. You've got vertical scaling, increasing the transactions per second, and then you've got horizontal, where you basically deploy a second blockchain that has the same security guarantees, but has an entirely new funnel for processing transactions. There's a lot of benefits about minimizing the surface area for security, having different cadences for the upgrades. And the second one is called layered security, where you'd be able to take a blockchain that already has a validator set and do kind of like a business-to-business deal where you rent security from another blockchain. So you could imagine that validator set coming down is mixed together with the existing validator set and creates a new one that's a combination of both of these staking tokens in order to layer the security on top of each other. And what's kind of exciting about that is it really opens up the possibility for kind of business-to-business mutual insurance. You could have something like the Terra blockchain decides to rent security from the hub, and the hub decides to rent security from Terra. So the attack vector for either of those networks increases greatly, sort of removes a whole category of rug pulls. But the other really exciting feature about this is developments around Tendermint 2.0, project called Paxos, partially synchronous transactions or something. I can't remember. They change the name every day. It's blockchain. But if you get a threshold of the same validators across two networks, you can actually have synchronous IBC transactions, which bring back the atomicity and all the sort of arbitrage opportunities for these different DeFi protocols that we've come to love and expect inside the Ethereum space.
We also have seen interesting note from Flashbots, who's done a lot of this work on Ethereum. Many people expect that in the asynchronous context, arbitrage will look quite different, or arbitragers would prefer the atomic context. Actually, recently on Ethereum, we started to see this really interesting behavior in which arbitrage bots, in order to be the most gas efficient for a given arbitrage, it has gotten so efficient that bots have started to take price risk. Or hold price risk themselves. So we've actually started to see what were previously atomic single block arbitrages start to be done in an asynchronous fashion, i.e. an arbitrage will come in, make only the first leg of their trade, and then wait 10 blocks to close it when the gas price is lower, and hold that risk themselves. Potentially they're hedging it out elsewhere. But it raises an interesting question as to whether atomicity in the synchronous context is actually the sort of natural state, or if there are many contexts in which MEV and arbitrage like actually might be naturally asynchronous or be able to be done more efficiently asynchronously. So kind of interesting.
Interesting. I mean, speaking of creating efficiencies around these DeFi protocols, there's a new primitive coming to our space, staking derivatives, that Zaki, you've been really involved with. Some would say it's a way to make staking more efficient. Security. Can you tell us a bit what that is and why you think it's important?
So one of the things that I think that we're seeing is we are seeing this emerging Cosmos Phi ecosystem, which is native DeFi applications to the Cosmos ecosystem. Osmosis is like sort of the premier example of this, but there's a lot more coming. And what we need in these environments is we need capital. But in Cosmos right now, most of the atoms are staked. Most of the atoms are staked. And so they're not a source of capital for the DeFi ecosystem. And what we are starting to see is as more and more liquidity sort of flows into various farming schemes and fair launches that happen over the emergence of the Cosmos Phi ecosystem, you have this like starvation of not having enough atoms available. So one of the things that I'm working on is a protocol that will allow sort of any staked atom to be turned into a staking derivative, so that you will have a transferable representation that can be used to collateralize DeFi protocols all over the Cosmos network.
I've also heard this purported to be a hedge against the centralization through exchanges. Do you feel that's a prominent definition of it, or it's actually not going to be as important?
So the biggest problem that every proof of stake network has right now is the dominance of centralized exchange staking. The emergence of sort of soft staking is a very common thing on centralized exchanges, but it tends to concentrate the stake excessively in those centralized exchanges. And our only real opportunity to sort of push back against that is to build a staking derivative type solution so that people see significant financial upside to not holding your tokens on centralized exchanges. So far, the biggest upside has been airdrops. And that'll probably continue for a while. But you don't see your airdrops on your APY dashboards. So that doesn't entirely sort of propagate back to the end user as why you shouldn't be staking on centralized exchanges. But if you have all this opportunity to interact with DeFi protocols, with your stake atoms, if you are directly custodying and staking your atoms, that becomes a new way of incentivizing people to move their coins off exchanges.
It's like these exchanges are becoming custodial layer 2s or something like that with their own product offerings. Speaking of other networks, Charlie, IBC is shipped and ready to work inside the Cosmos SDK. That's why we've seen all these Cosmos SDK chains launch with it. But IBC was designed to be as flexible as possible to work in as many scenarios as possible. Where do we see it popping up besides inside of the Cosmos SDK?
Yeah, I think that's a really good question because it's a really common misconception. And I mean, I even had it myself before I entered the Cosmos space, that IBC only works with Cosmos SDK chains. What IBC actually is it's a set of abstractions. And so it's a protocol that defines certain message types. It's like a container, a generic container that can contain anything inside. And so because of that kind of design, it actually IBC is integratable with a lot of chains, with most chains. I mean, obviously, we need finality. There are some chains that are hard because they don't have a concept of a light client. But all you need to integrate with IBC is basically three things. You need the IBC logic in whatever language your chain understands. You need the light client, which is, light clients mean a lot of different things these days, but what it means in IBC is the kind of a consensus algorithm. So it's a way that you can basically prove the chain state on the other chain that you're connecting with, and you need this on both sides. And you need a relayer, which will support these transactions, and that's it. So currently, we have IBC integrations ongoing, and the closest one to being done is the one with Celo. And this one we're really excited about because it's an EVM chain. The way that the WASM light client development environment on the Cosmos side has been designed is really cool because it's quite modular. So if you plug in another signature type, you could theoretically verify any kind of EVM chain. And so we're really excited about that integration. We also have an IBC substrate palette in the works. The first design is for sovereign substrate chains, which determine their own finality, which is a lot of chains these days in the substrate ecosystem as they wait for auction slots to open up in Kusama or Polkadot. But obviously, the next iteration would be to support parachain and parathread slotted chains, which have the relay chain kind of determining their finality. Yeah, so I think it's like, it's really exciting for me to see the IBC ecosystem growing in such a way that we are really beginning to accommodate for a larger ecosystem. It really is like this internet of blockchains thesis that was in the original white paper, and we're really beginning to see come to fruition in the past year.
I mean, you mentioned a bunch of different public blockchains and chains that plan on launching public, but one of the features of Tendermint, Cosmos SDK, and IBC that I've always really appreciated is that, or I think it's undersold, is that it sort of fits so perfectly for enterprise use cases. I mean, Tendermint was originally going to be this enterprise company, right? 2014, they were like, cool, this is how we're going to make an impact, and then totally, I don't know what kind of trip you all took.
Thankfully failed horribly.
And decided actually public blockchains is the way to approach this in the future. But I think we've seen a lot of enterprise projects start to recognize that the features of the tech stack really fit perfectly their needs, and that those ones are also starting to really pay attention to IBC. I was wondering if you could tell me a bit about what we've encountered so far with that.
Yeah, I actually forgot to mention, so sorry for that. But yeah, I forgot to mention so we have a lot of enterprise integrations also in the works, Hyperledger Besu, Fabric, and Corda being among the first three. And yeah, and I think what you just said is really important because in cases where, in a world where we want any kind of entity or person to be able to participate in a blockchain, we need to realize that only public blockchains won't be able to solve for that use case because there are just a lot of situations where an entity, because they need security for their validator set, because they don't want dynamic validator sets, et cetera, they can't participate in a public blockchain network. And so being able to support enterprises, but more importantly, being able to view IBC as a way to conduct distributed business processes across various entities, whether or not you're in a regulatory or enterprise environment, or whether or not you're in a public environment, is something that I think is, it's something that's not talked about as much, but very important. And we can see a lot of these being developed, in the CBDZ cases, in, like I mentioned, distributed business processes across multiple entities. Yeah, and I think this is also a lesser talked about but very important application of the blockchain technology.
And what's amazing is that they also get access to public networks because IBC, of course, can pass those borders through. Mm-hmm. Charley, Paradigm didn't exist when the Cosmos public sale even happened. You guys must have gone through some hassle becoming Atom holders. But I'd be curious, what was it while you were comparing Cosmos with other projects that really stood out for you all?
There are many people trying to run many applications on on like a single given blockchain. Cosmos is still the only, I think, that has like credibly attempted the model of many blockchains running individual or like a small number of tightly correlated use cases, and then providing like the interoperability sleeve to make that like feasible as an ecosystem, not just siloed individual projects. Like at a very high level, I think that's just interesting and different than what really anyone else is doing like in crypto.
Speaking of beginning of the project, Zaki, you've been here the longest than anyone on the stage. How have you seen the development of the tech change over the years, the organization, the system, and how has that impacted the cadence of the project and the direction itself?
So I think one of the most ambitious things that we have move to, and you orchestrated a lot of this, Billy, is this move to this like 40 entity distributed development system. And the thing that is most encouraging is that it seems to work. And there are now a variety of different funding sources for Cosmos Core Dev, not just the Interchain Foundation, not just any of the original, the original fundraiser, not the original, the original treasury. We have like basically moved beyond that, and I think we are one of the only projects in the space where core dev is spread out across so many different funding sources and so many different business models, and that basically makes Cosmos likely to last forever. There really are very few or perhaps no single points of failure left in this project, and so one would expect, that Cosmos will likely outlive me and everyone else on this stage, and that's kind of a really cool place to be.
That's the goal. We've got 30 seconds left. I wonder, Charlie, you're the newest. You're coming, though, from Substrate background, the Polkadot, and especially the Ethereum background. I'd be curious, as you've landed in the Cosmos space, how do you compare those ecosystems, those communities? What's been the thing that stands out to you the most?
I mean, gas prices, availability of no slots, the loving community, like a big, happy, dysfunctional family that still loves to stick together. So I really appreciate being here.
Love to hear that. All right, that's our time. Thanks very much for coming. Charlie, thanks for calling in. I think we've got our moderator. Thanks, you all.